What's the square root of 103? Well, it's not too far off from the square root of 100, which would be 10. So the square root of 103 is probably a little bit bigger than 10. Well, how much bigger? Well, what we're going to do is we're going to use the derivative and the notion of what we call a differential, which we'll explain over the next couple of videos, to get a pretty good approximation of the square root of 103, knowing the square root of 100. Okay? And what we do is this. We have a function, the square root of x. We really want to know what the square root of 103 is, but we'll settle for 100 plus a little bit of fudge factor, right? So what I do is I say, well, I've got this square root function, right? I know that at 100, the square root is 10. What I want to know is at 103, what's the square root? Well, that's harder to calculate, but I can use essentially the tangent line to approximate the value. So if I were to say, I'm going to move over 3, how far up do I go? Well, the rise, let me see, how does this work? Slope equals rise over run. So the rise is the slope times the run, right? Now, what I'm going to do is use sort of calculus notation here, in that you've got a little change in x here, and you've got a little change in y, and actually, rather than using delta x and delta y, I'm going to use what I call differential notation. This is good notation, but still I want to use this. I want to use dx and dy, where I think of dx as a small change in x and dy as a small change in y. So how small? Well, really small. But the idea is that the slope of the function here, that f prime of x, is the change in y divided by the change in x. And it actually just looks like, the two ways of notating the derivative, but it really is a fraction of change in y divided by change in x. And so the change in the y value, dy, is the slope times the change in the x value. That's this here. The rise is the slope times the run. The rise is the slope of the line times however much change you have in the x direction. So, looking at this here, I can say that f prime of x, let's see if I can, there we go, f prime of x, take the derivative here, that's 1 over 2 times the square root of x, right, because it's a half, x is the negative a half. At x equals 100, so f prime of 100, the slope is 1 over 2 times the square root of 100, which is 1 over 20, which is 0.05. So what I know is that the slope at this point is 0.05, and so the change in the y value is that slope times the change in the x value. Well, the change in the x value from 100 to 103 is 3. So this is 0.05 times 3, which is 0.15. So apparently, at least approximately, as you change the x value by 3, the tangent line at least is going up by 0.15. And so I'm going to guess that the square root of 103 is approximately equal to the square root of 100, which is 10, plus this little fudge factor here, 0.05 times 3, or a total of 10.15. So this is my approximation of the square root of 103 using the slope of the tangent line to get there. Now, what is actually the square root of 103? Well, I turn on my handy dandy calculator and I ask it, and it tells me that the square root of 103, at least rounded to 8 decimal places or whatever it's giving me, is 10.14889 157. So an estimate of 10.15 is really not too bad with a 10.1488. This is what we call a linear approximation. I don't know how many P's there are. A linear approximation, and in the next video I will do this in general.